Jeff said that everybody in this room can help solve all the problems we have in making smart video monitoring. So I figured what we would do is just quickly kick off with a summary of some of the challenges both in processing power, memory, bandwidth, precision, recall, usability, all these things around how to make video smart, and then just talk about how we solve some intermediate level, and then talk about some of the remaining problems even after some of this next generation stuff comes to market, which we're eager to exploit as soon as it's available. I'm Carter. Luca and I are co-founders of Camio, and we're just going to go through quick demos. The first one, Jeff was mentioning that a lot of the machine learning is just determining what's interesting out of 24 hours of video, all geared towards stationary fixed cameras. So the first thing Camio does is, as you scroll your feed, it's super fast to just see the highlights, and there's no dead air events. It's all stuff that the machines have learned are interesting to you. And I'm going to show demos on this screen, but the core use case that's both for search and alerts, people approaching east stairs in blue. Oh, it didn't. People approaching east stairs in blue. And instead of hours of video to watch, in less than a second, I'm seeing only people that were approaching the east stairs in blue. And this is applied also to other kinds of labeled events, but that's the goal behind Camio, is how do you make video monitoring delightfully fast so that you don't even have to watch the video. Google and Luke and I worked at Google together, and one of the things that we were contemplating was that everything that you can search and get alerts on now was stuff that's published on the web. So why can't you have a private camera tell you stuff about what's happening in the world without having to type anything or publish anything? So that's what we're going to go over, how we did this. So some of the basic examples are these, where you can do a search for like gray minivan in front of my house, and it'll just show you gray minivans, or people approaching the driveway, or I'm going to walk through one for the project that we're doing with the Nature Conservancy, where you can actually have classified types of fish that are hauled up on long line fishing boats as part of the fisheries observations. But all these examples are really just trying to make video very fast and searchable. Here's the biggest challenge, was that you've got hours and hours of video, a lot of the time completely boring. And Jeff was mentioning in the home setting, but it's the same thing in a boat setting or a business setting. Out of all of the hours, it's very rare that something warrants your viewing. And I'll just do a quick demo of the search that we do in this. These are, I didn't know this about the fishing industry, but it's a $190 billion industry. And they lose about $50 billion in mismanagement of the fisheries, whether it's through excessive regulation that restricts when they can fish, or just mismanaging the population of fish so that they have less to sell. And so one of the things that they're trying to do is have electronic monitoring companies that currently report in a latency of about 3 months, shrink that to be real time ultimately. And that's where I'm going to use this as an example, because I think it pushes the boundaries of what we want from this group, whether it's processors, low power consumption, on-device annotations that use very little bandwidth. All of these things are pushed in this scenario, but this is what Camio does today with the imported data from a boat. And I'll just play this real quick so you can see that there's just hours of video, but then what they want to be able to do is count how many yellowfin tuna were captured. And so here we're doing a query for tuna. It shows all the times that tuna was on the boat. You can click to play the actual video behind it and see, okay, there's one. And we want to do things like measure the approximate size and stuff, so I'll go into that later. But you can do the same thing with marlin. So you do a query for marlin, and now you've got when the marlin came on board. And so the idea is that this metadata annotation should be possible on the device, not just let me just see if I can go back to the presentation. Not just in the cloud, because right now what Camio is doing is a mixture of edge computing and cloud computing, and we're going to go over some of the workloads that are in each when Luca talks through the whole pipeline. So these were some of the historical challenges that Camio solved in its first round. there's a fragmented camera and NVR SDK in market. If you want to predicate getting smart video by getting something onto a camera or NVR, you're going to have a long time to wait. So we kind of sidestepped that with an intermediate solution by having this video gateway that's a small quad-core ARM A53 processor that can basically analyze video streams on the local network, no matter which camera it's coming from or NVR it's coming from. And so that was the first thing that we mitigated, was just being able to get to market and make all streams smart, no matter which camera they came from. The next one was just expensive cloud compute. If you were to do labeling in real time using deep learning 24/7 video at the normal frame rate, it'd be tens of thousands of dollars a month. And so how do you do that at a consumer price? That's where Luca created some fantastic real-time event ranking so that you could know which parts are important enough to warrant the deep learning labeling. And we'll go into that when Luca walks through it. Another problem was limited internet bandwidth. So you can't just stream video unless you want to take out your entire data allotment. Like Xfinity just rolled out 1 terabyte monthly data limits, and you can use a third of that if you have one Nest camera, because they're just continuously streaming. So we have a metadata first pipeline is what we call it, which is basically allowing the local processing to happen locally so that you can just do the full definition video when it warrants it. And since so little of a day's video is important, it ends up with huge bandwidth savings. And false positives were the other problem. If you look at the motion detection that's built into most cameras and NVRs, it's a huge number of false positives from blowing leaves, shadows, things that you would normally consider spurious. But the additional part to that is that there's some real motion that's not just pixel motion. Like the branch is literally swinging all day long, and that really is a branch swinging that's a real object. It's not just artifacts of compression. And so we have adaptive motion filters that eliminate those false positives as well. And then the last problem was diverse workloads. You've got everything from queue management to upload priorities to which things get labeled by what level of services, because it's all about trying to get this to perform at a low cost with great precision and recall. And so we've developed a pipeline that has places for hooks and callbacks into a whole bunch of other labeling services at different points in the pipeline. So this is our Camio. What it is at its root is it's a service much like Stripe is for payments. We want to be for video. So if you just want to make any video stream smart, we want to be the easiest and simplest way to do this on a white labeled basis. So we partner with manufacturers to ship solutions that are branded in their brand that have this smart video consumption experience that we can demo. But the basic architecture right now is that you've got any kind of camera input that's an RTSP H.264 stream, and then there's some firmware that runs on the network that is in this chatty conversation with the cloud. Like, hey, do you find this interesting? Yes, no. And that chatty conversation is efficient, and it just enables you to make cloud-informed decisions, because right now the cloud still does have some advantages in its knowledge, like it's raining in Burlingame, so these night streaks can help influence your judgment because it's got a perspective that expands beyond what the context of the camera has. So, but the end result is that you just be able to do what I did on my phone. You could just say sport utility vehicles in my driveway and then see a quick summary in less than a second. The reason that we are focusing on it now is that it's the first time that this has been feasible. It's only the last 2 years that some of these deep learning things have been possible, and you're finally getting, inexpensive compute power at the edge, combined with people's social expectations, which had gone from, is there any video of that, to like, where is the video of that? So I think people are increasingly comfortable with being able to teleport to any location, whether it's their business, their robotic arm lab, or their fishery on a South Pacific. They just assume you should be able to have a connection and video to know what's happening in the world. And so we think this is a good time to be doing what we're doing, all of us in this room. And with the goal of not just having hours of video, but answers to questions. And these are just some examples. You can say the one I just did, people in blue approaching the stairs, sport utility vehicle. And all of these are enabled by the pipeline that Luca has been the chief scientist and designer of, and he's going to walk through the elements and how they can be flexibly allocated between edge and cloud. And so Luca, if you could introduce the pipeline.
Thank you. So, okay, we were a company that was originally born entirely on the cloud, and we started moving more and more components to the edge devices to essentially keep the cost down and keep the response time up. So what we built is essentially a framework in which pipeline components can be moved from the cloud to the device easily.
The box is what we just call the edge processing. So assume that could be the same as what's in a camera firmware, but this is like an intermediate gateway device. And so the big part and box is just the basic motion detection, but then the removal of spurious motion. So the high frame rate on the local video, you can separate the fact that there's a white Toyota Prius passing in the background, even while all of the shadows and reflection on this car windshield is going all day. And this is what the common problem is with just stationary surveillance cameras, is that it's hard to weed out these things because they're significant movement that you would want to pay attention to. And so this first part is what Camio calls the adaptive motion filter, that learns quickly when there's a breeze passing by or any kind of transient, repetitive, real object motion, so it can isolate the thing that actually moved. And then the scene recognition is helped by the cloud. That was what I was saying about how the cloud has a unique ability to say, oh, these common rain streaks or this blowing spider web, it has more knowledge about these general scene conditions that can further filter it out. And then the cloud is also just learning, because the cloud's unique in being able to process the feedback from users. When I play an event in my phone, that's an implicit statement that it was interesting. And if I want to explicitly train it, I can give it a quick thumbs up and down like you would a Pandora song on a radio station. But that feedback is critical because that's the way that the cloud influences the learning model for the camera. So that's squarely in the cloud. And then all of the indexing and storage for fast search and access, one of the things that we wanted to do was make sure that you didn't have to open network ports and forward stuff insecurely and end up with things like the Mirai virus that have these massive denial of service attacks because of, I mean, really, it's kind of like the irresponsible consumer device instructions on everything in the market right now, where it says, you know, enable plug and play, forward your ports, send passwords in the clear. It's really bad. So we were using the cloud as at least a way that can be encrypted, stored in disk with keys that only the user can access. Everything uses perfect forward secrecy. So then the final part that's done on the box, this is like server cloud up here, the box down here, is the accelerated time lapses. So when it's not significant, it does the accelerated time lapse. So this gives you 24/7 continuous coverage without the bandwidth consumption of uploading HD all the time. So these decisions in the cloud are affecting the behavior on the box locally, so that I'll show some transitions between time lapse and HD based on interest level. I think we had one back here, perhaps. Yeah, this one here. So if I watch this, you got to watch carefully because it's low res on a screen here. But watch how you're seeing a scene where there's a blowing chandelier, there's ivy blowing everywhere. That's all accelerated time lapse. But then when somebody walks into the scene, it goes into HD automatically. So I'll just play that real quick so you can see an example. So here you can see the fast. Let me just replay it because I think it started before I had it on full screen. So. Sorry. So you can see this is significant movement with the chandelier and the leaves and stuff, and it's all very low-res accelerated time-lapse. But then as soon as somebody comes, it goes into regular HD with the full frame rate. And so that was that last box that we were describing as the accelerated time-lapses based on the learnings for each individual camera. And then, so the part that, this is the current, so we're going to just build it out. So this is, the next release is moving, let me just go back, the ML object recognition down to the box. And this is moving both TensorFlow models to run on the box, as well as a vocabulary that's kind of limited. So I think we'll probably take whatever we can afford to run locally and do as much labeling as we can there. There's increased processing demands, which kind of makes us always in a balance between how many channels you can support versus how much labeling you do locally, and balance that with cloud costs. So we can go into that in more detail, but a lot of these decisions on where things go are not just around bandwidth efficiency or precision, but it's also on cost and where you can do things most effectively. So our next one will move more and more of it to the local edge device. Along with the scene recognition, that'll soon move in the June timeframe. This is a little bit out of sync. And then in terms of the important for the user or not, I didn't really understand the moving that to the box. This was what was the point on that one?
So we have this labeling. The users can tell us whether something is important to them or not based using thumbs up and down feedback on the web app and mobile app interfaces. Mm-hmm. And based on that, we do classification, and we decided to process the video differently and upload it or summarize it or not. This is actually done at a very low processing cost. So we want to move it last to the box because actually it's not the major part of our CPU cost. So we want to move it on the box just as a matter of optimization. If we move that to the box, then we can do some other optimizations in the process. But the fact is that the other learning models, such as the object recognition and the activity recognition, those are built across many users. I mean, of course, object recognition works across all users, and so does activity recognition. RAIN looks pretty much the same on all the webcams. So those are models that are very complex, that are very computationally intense, and we get a lot of benefit by moving them to a particular edge device, to the edge device. The user-specific learning instead needs to be trained on the basis of input from each user, has a much lower latency learning and the deployment latency, and so it benefits us to keep us in the cloud as long as possible, but eventually I think we will be moving that in part as well to the device.
I see. So, I mean, there was an implicit part that we didn't cover about putting stuff on the edge, which is just event segmentation even. So when you go back and rerun your learning across past events, the fact that you're doing stuff at the edge and have this kind of very good linear time view of everything that happened makes it very efficient compared to the cloud, where the cloud's got to juggle all these asynchronously arriving events and you have to reconstruct them and go through them in the cloud. That's more expensive too. So there's a lot of advantages in moving as much of this to the edge as possible.
Let me do an attempt more to cover.
Yes.
I'm sorry, I have a sort of so we built a pipeline that essentially is composed of two portions, a portion on box and a portion in the cloud. And what keeps them in sync is a flow of metadata up, aside from the video which we upload. But we have metadata that goes up that says essentially this is an event started at this point, ended at this timestamp, and contained these characteristic objects in it and these characteristic flows and of motion, etc., etc. And on the other way down, we have a very extended language that says, for example, upload these, store it locally, give us debugging information on the status of the device. We have all kind of debugging that went on. So we have essentially developed this flexible architecture, which now enables us to do things such as, if you go to the next slide, We can actually do the one after this. We can skip. We can do things such as metadata-only deployments. Suppose you're a large organization, such as a university or a company campus that has maybe hundreds of webcams. You can, of course, rely on us to upload all your video because we are very scalable as infrastructure. But maybe you don't want to do that because you have already developed your own ways to store the video, and you want, for privacy reasons or secrecy reasons or whatever reasons, compliance reasons, to have the video on your site. So you can use our edge devices to do all the computing, but actually skipping the video upload step. You upload the video to your own storage, but you upload all the metadata to us, so that if you go to the next slide, when you do a query, you can query our servers that act as smart indexing servers. So the query is processed by us, for example, people approaching entry, and we give the results of that query in terms of web pages that can be displayed with the cover image of what happened, so that you can sort of make sense whether you want to play that event or not. But when you play it, the video comes actually from your video storage via proxy server. If you want to be able to see it from all over the place, then you have a proxy server that can serve outside your organization. Otherwise, you can view it only locally. And this reduces in an incredible way the bandwidth you need if you're for a large organization. You go from 200 kilobit per second for every camera that is a video feed produced by each camera, and you go down to 30 kilobit per second to process the metadata. That is 30 kilobit per second is still quite chatty, but we need that level of chattiness to be able to catalog all the video, do all the machine learning that we need on top of it, learn whether that's going to be interesting for the user, yes or no, and send it up to the cloud. Or I mean, in that case, you know, the cover images split up in the right way.
Yep.
So we have three types of hardware that we use on edge devices. One is we call it the Camio box on the left, is really an ARM architecture based on it's a commercial Odroid actually that we
the Odroid
sell,
C2.
C2 that we sell as our Camio box. But so it has a quad-core ARM A53 with 2 gig of RAM. And the next step up, that enables us to process 3 camera feeds. We essentially use 1 core per camera plus 1 core for general things such as management, debugging, upload stream, and other tasks. Then we have a Box Pro that is based on Intel i5 architecture. It's just essentially a general Linux machine. So it can process up to 16 cameras. And what we didn't know, but we at the beginning, and we did that as an ad hoc solution, but is becoming more and more popular, is that we give our product available as a virtual machine. So people that already manage data centers, think at a company or university, can simply download our code, run it into the VM. They can use as many VMs as they want, and they can, just provision us on demand just by, buying more subscriptions to us, in order to be able to process more things on the cloud and on the device. So if we had to have our wishes, we were told that you can solve all our problems. I think the main pain point is the first. So we were born as a company that wrote in pure Python and NumPy and whatever, because this was very scalable in the cloud. Using things like a Google App Engine, we can instantly provision 1,000 cameras in 5 seconds or something like that, right? And then we are now working on these edge devices that have a much more constrained architecture sometimes. So one of our wishes is how can we easily port code that is written in a mix of Python, NumPy, and some other packages. We would have a list of packages available, but how can we port these more quickly and efficiently to these architectures of systems on a chip in the most effective way? So we love package repositories, and we love anything that makes this kind of software porting easy.
And the big point here is that a lot of times when we're talking machine learning and computer vision, we're only talking about those things. And Luca has an expression that I love that he used to say at Google, which is he spent 90% of the times as a plumber and 10% as a theoretician algorithm. And this is the same thing in delivering this smart video monitoring, is that there's so much value in all the stuff around the grunge plumbing for queue management, uploads, all of the stuff on prioritization of how you're taking motion vectors out of videos and stuff. There's plumbing work.
Exactly. So it's not only the complete, so to say, sophisticated algorithms constitute probably 3% of our code base, and most of it is other things. We have incredibly sophisticated, remote debugging, remote firmware management, remote queue management, so that we know if we have poor connection to upload only the right portions of the videos and how to optimize, and all of that is very efficiently written in a high-level language such as Python that manages, HTTPS connections for whatever we want, etc., etc. So it's not only the problem of how to port a pure deep neural net to a particular machine with a GPU, but we have a wider stack in a sense. We are a fairly for example, we have a part of our application can scan a network and discover automatically all the webcams in it, register them with our application, and maintain all this communication with the cloud. And in order to develop that efficiently, we are this high-level written application, I think. Mm-hmm. So another thing that we would like is in our wishes, and it is instead, I wouldn't say instead, but this is certainly addressed by a lot of the work here, is we want to try to move as much of the expensive ML, expensive in terms of CPU cycles, to the device. So these, originally we were based on our own machine learning libraries. We are now trying to standardize more on TensorFlow, hoping that this will be a way to deliver our machine learning to GPU speeds in a more effective way. But this is also one thing that we need to do. There is often limited internet bandwidth where we need to deploy, and so if we can have dual resolution video feeds coming out of webcams, so that we can avoid the cost of recording video streams to lower resolutions, this is better for us, obviously. We also love hardware platforms that can give us help in not only displaying encoded video, but also decoding the video to, for instance, extract the motion vectors or do processing on it efficiently. So any hardware platform that enables us to do that will give us leverage. And another problem, which I'm really not sure whether there is any help available in hardware or by the people of this forum, but it's a problem out there, is the one of firmware updates. So in the good old times, before I moved to Vision and I did anything similar, I used to work on formal verification of software, in which we were trying to make sure that a mission to Mars, say, would not fail midway. And now that I'm doing embedded devices, really having a device in a person's house is the most similar thing to a mission on Mars I've ever seen. Because you cannot trample into their house and start playing with the device to figure out what's wrong. And one of the things that is critical is, in fact, ensuring not only that the code is correct, but that we can reliably get the state of the code and get an update up there. And again, we are not one of these very tiny, and I wouldn't say very tiny, but very streamlined software packages that can be down, so that we can download the whole OS in a single download and replace the whole running system because it's only 30 megabytes. We are built on top of Linux, we are built on top of these packages, so we need to be able to do package management and firmware update management on these remote devices. We believe this is a need that will become more and more common. As more and more people, for instance, will use TensorFlow, more and more people will need to have a Linux stack, etc. We have our own solution to do firmware updates that are validated and that can support rollbacks in this complicated environment. But certainly, if there are other solutions, or if there is any other thing around that can make this process more foolproof and less painful, even simply standardizing on more distributions or package management, this will be great for us, I think.
Yeah. So that's our wish list. Our other request is that we sell Camio as a white labeled service, so can partner with any of you and your customers in trying out stuff that you've got early. Like we're like a petri dish partner in that we can iterate quickly. If you've got a new chipset from Qualcomm or something that you want to put in box, we're assembling boxes only be as like our experimentation framework, because we have hardware partners that are putting Camio firmware into their NVRs and cameras, but they don't come out till Q4, and so we iterate before then. So we're happy to partner with you guys